Alright, this problem we are going to be using a concept called STP to solve for the molar volume of something. So it's going to be a little bit of a departure from the gas laws that we just learned. But basically, STP stands for standard temperature and pressure. And standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. So for gases at STP, all of them occupy 22.4 liters if there's 1 mole of gas. And so knowing that number, we can actually write a conversion. There are 22.4 liters per 1 mole of gas. Or, depending on what type of conversion we want to do, 1 mole of gas contains 22.4 liters. Now this is only, make that a Y, at STP. So when we're under those conditions, 22.4 liters of a gas are contained in 1 mole, or 1 mole of a gas contains 22.4 liters. So for this problem, it's asking us what volume is occupied by 64.0 grams of oxygen at STP. And this is on slide 76 of our chapter 11 PowerPoint. So somewhere in this problem, we're going to use this conversion that I just wrote, this 22.4 liters per mole. So first we got to figure out what we're looking for. We're looking for a volume. So I'm going to write question mark volume. And the only number we're given is 64.0 grams of oxygen. So that's what I'm going to start with. That's the only number that I know right now. Now, at some point, we're going to use this conversion that we just wrote down, this 22.4 liters per mole, or vice versa, but we're currently in units of grams. So, to use this conversion, we're going to first, before we can use it, convert our grams to moles, and we do that by dividing by its molar mass. So, you go look at your periodic table, which I know you all have handy sitting right next to you as you listen to this. There are 32 grams of oxygen, O2, per 1 mole. And that's because, remember, oxygen is diatomic. It has 2 atoms. So, we can write 32.0 grams of O2 per 1 mole of O2. That's our molar mass, and that's going to cancel out grams. Now we're in a position where ultimately we want to know volume, but we're given grams. We've converted to moles. So now I can use my STP conversion to cancel out moles and solve for liters. So for gases at STP, which in this problem oxygen is our gas at STP, we can say in 1 mole of oxygen there are 22.4 liters of oxygen. And that cancels out our mole unit, and we are left with just liters. So all of our units have canceled except for what we are looking for, that's 22.4 liters of oxygen. So now the last thing we have to do, we multiply 64 times 22.4, and that answer you take and divide by 32. And if you do that, you get that the molar volume of oxygen at STP is equal to 44.8 liters if there are 64 grams.